Okay, so in this video we are going to be talking about the Ostwald process. So feel free to pause the video and copy the notes and then follow with me as I explain. So the Ostwald process is just simply the industrial manufacture of nitric acid. Okay, the industrial manufacturing of nitric acid. And just like the contact process, there are a series of reactions which follow it up. Like a good example, we are seeing that firstly, nitrogen is being reacted with hydrogen to produce ammonia. So ammonia is the first thing that is being produced here. Now, this reaction in which we are seeing nitrogen and hydrogen being reacted directly to produce ammonia, this is what is known as the Haber process. So anytime nitrogen and hydrogen react in this way, reversibly, this is what is going to be known as the Haber process. So the Ostwald process always begins with the Haber process. So the ammonia that is going to be produced now is going to be oxidized. It's going to be reacted with more oxygen. And when the ammonia is oxidized, when it is reacted with more oxygen, the byproducts are going to be nitrogen monoxide and the water. Okay, nitrogen monoxide, there is one oxygen there. So nitrogen monoxide and the water. So from these products, the nitrogen monoxide is going to be reacted again with more oxygen to produce nitrogen dioxide. And then afterwards, the nitrogen dioxide is going to be hydrated. That is, it's going to be reacted with water again. And when nitrogen dioxide is reacted with water, what we're now going to have is nitric acid and nitrogen monoxide again. So in this reaction, we are not only just having nitric acid as the only product here. There is another byproduct, which is nitrogen monoxide, which is going to be produced. So in the fourth reaction, nitrogen dioxide is being hydrated to form nitric acid and the nitrogen monoxide. When the nitrogen monoxide gas has been produced, it can again be reacted with oxygen to form nitrogen dioxide, and the whole process continues again. So this nitrogen monoxide can be recycled back in equation number 3, and the process will continue again. That's why I have written it for you like this, to say that the nitrogen monoxide is then recycled into equation 3, and the process starts all over again. But if you want to have nitric acid as the only product here, you can just react the nitrogen dioxide with oxygen and with water. Here we only reacted nitrogen dioxide with water, but here we can react the nitrogen dioxide with water in the presence of air, and once that happens, the only product that we're going to have is nitric acid. That's why I have written for you to say alternatively, or I can say in other ways, nitrogen dioxide may be reacted with water in the presence of air to only produce nitric acid. So note the difference here. And of course, again, the reaction conditions for this problem. Temperatures as high as 600 degrees Celsius and 900 degrees Celsius to 900 degrees Celsius are applied. The pressure is rather small a bit, but more than the contact process. The pressures here range from 4 atm to like 10 atm. And the catalyst that we use here is platinum. Okay, platinum is the one that is used as the catalyst. Even under the contact process, platinum can also be used, but the common catalyst used in the contact process, the manufacturing of sulfuric acid, the common catalyst that is usually used there is vanadium 5 oxide. So this is the Ostwald process. And the nitric acid produced is also a strong acid. It can ionize completely, and it is also inorganic because we're not seeing any carbon atom present. And I mean, the fact that we're even manufacturing it, then it is not natural. It's somewhat man-made. It's a mineralized acid. It can be manufactured by man. So it's man-made. So that's what we can say. And this is the Ostwald process.